So, good afternoon everyone. Myself Shanmugaraj and I am currently doing PhD in Indian Institute of Technology Madras under Dr. Benny Raphael sir. So, my topic of research is the quality monitoring of concrete 3D printed elements. So, as the title is running on, there is a background video. You can see the 3D printing, it might look it's running good and all, but there will be a sudden collapse and it's going to be a failure. So, like this there are like so many uncertainties in concrete 3D printing. So, we are in the process of getting maturity. So, coming into this topic, we need to understand the basic differences between conventional construction and concrete 3D printing. So, in conventional construction, we have large volumes of concrete with sufficient factors of safety. So, any minor variations will not have a major impact. But in case of concrete 3D printing, we don't have formwork and thin layers are extruded. So, any minor variations in the print mix or the printer properties is going to affect your structural and durability aspects. So, take this example. So, this is a 3D printed element. So, you can see that the bottom layers are not having so many voids, but as you go to the top, the number of voids are getting increased. So, this is the problem of extrudability. So, the bottom layers having a smooth surface texture. As you go to the top, you have more granular texture with surface voids, which ultimately leads to the discontinuity of the printing. So, how we can actually assess this, how we can capture this in real time. So, there are some people, there are researchers who have worked on identifying these extrudability properties, but those are not in real time works. So, how can we do it in real time? So, what I try to do is, I try to keep a camera, I will try to assess the surface texture of the images taken out of it. So, by capturing the surface texture, we can actually identify what is the actual extrudability or the workability of the concrete. So, what happens is here is, as you go to, from the bottom layer to the top layers, with increase in time, there is a decrease in the workability or moisture content. So, do we have any quantification in real time monitoring? Until now, there have been some studies, but still it is a major problem in concrete 3D printing. So, as I said, these are some of the tests which are available currently. These are mechanical tests and which cannot be run in real time. So, where can we take? So, there we can, if we can see the quality monitoring in other industries like additive manufacturing. So, where there is fusion deposition modeling, where the 3D printing of plastics happening. In that, there have been like number of publications which have focused on quality monitoring and control. So, for example, you can see that from 2014 to 2019, there is an increase in the number of papers which are focusing on quality monitoring and control, but which is not that much extent in concrete 3D printing. So, in these papers, so most of them have used 2D vision or the camera as an effective sensor technology to capture these variations. So, coming into my methodology. So, as I said, so when the concrete 3D printing is happening, I am placing a camera, I am capturing the images or video of the 3D printed elements when it is at printing. Then I am cropping the individual layers of images of the 3D printed element, and then I am extracting the minor and major textural variations. So, once this minor and major textural variations along the surface of the concrete is getting captured, we can develop a single measure for textural variations to actually identify the or to actually assess the quality of the 3D printed elements. So, these are the two elements that I have studied. So, this element A, as you can see, it is relatively a better quality printed element, but element B, you can see there are large number of voids. So, what I did is I cropped out the central portion to avoid the effect of curvature, and then I have given a designation for each and every layer as starting from L1 to L47, and then I have cropped the images. So, I am cropping each and every layer's individual images, which I am using as an input image, and then I am using different like filters like horizontal mask, vertical and the inclined mask to actually identify the gradients in horizontal, vertical and the inclined directions. So, this is a sample GIF. What is happening, like we are convoluting with a filter and we are getting an output. So, after this, many people will use a single threshold value to identify whether there is an difference in difference in the texture or not. But here what we are using is, we are using a number of thresholds starting from 4 threshold to 128 threshold, so that all the variations are getting captured, even the minor variations and also the major variations. So, once it is captured, so here you can see this is the same image, the same layer, when you convert it through like a different threshold values, this is how the difference in texture variations are getting captured. All the black pixels are the higher changes in the textures. So once that is captured, what I did is I am giving a weightage to each and every threshold value. I am giving less weightage to the minor textural variations and a higher weightage to the major textural variations, and then I am finding the weighted average of it. So once the weighted average is there, we can actually able to ascertain that what is the actual major texture variation in that particular layer. So, but to have an apple to apple comparison between the other elements, I have introduced the normalized weighted texture calculation, which actually uses the mean and standard deviation over the entire image to identify the normalized weighted texture values. So once that is obtained, so this is the graph you can see. So this is element A and this is element B. So element A, the points are captured here in black, and for element B the points are captured in red. So what we can see here is that for element B we know that it is an there is a number of voids present are very high. So here you can see that these 2 points in the initial layers. So I think you can't see very clearly in this image, but there are so much voids in the initial layers only. This is very well captured by capturing the weighted texture values here. And in the same way, if we go to the top, there are in the top here also, wherever the voids are there, the changes in texture are very much captured in using this weighted texture calculation. So in the same I am extrapolating into the normalized texture variation calculations. Here also I am able to get the same number of values. So whatever I am is there, wherever the voids are present, I am getting higher values in the normalized texture value. So whenever there is a higher value in the normalized texture value, so we can say that there is a presence of void in it. So if there is a presence of void in it, we can actually stop the printing or give a sufficient feedback into the printing system to actually change the extrusion speed and the printing speed to get a good quality print. So this can be correlated with the workability properties also. So this is the workability properties. So workability of that particular concrete mix from 0 minute to the 1/20th minute. So this keeps on reducing and the textural variations keeps on increasing. So when we correlate these two, we can actually identify an indirect correlation of the workability of properties without even actually touching the concrete or without even actually getting a sample of the concrete. In the similar way, I have done another one study where this is an image, this is a video of the printing is happening. So I have taken a particular crop window. In this crop window, so whatever the changes happening as the layers are getting printed, what the major change what will happen is as the layers are getting printed, because of the weight of the top layers, the bottom layers are going to get compressed. So whenever there is a change in the that particular window, that changes can be actually captured by the texture extraction. So this is a GIF where that changes are getting captured. So once the changes are getting captured, if the concrete 3D printed element is a good quality print, there should not be much change in the 3D printed elements. If it is not a good quality print, it's going to change completely. So this is what. So in this graph says that initially the changes are very high, but it gets stabilized as we go into the number of layers. So if the graph stabilizes, it means that our 3D printed element is a good quality print. So these are the conclusions. So through this study, we can actually identify a continuous non-intrusive method for identifying the buildability, extrudability properties, and which can be used to create a feedback control system. Second one is we can create this uses a normalized weighted texture value. So there is less sensitivity to the illumination levels, which will be the major difference between two different printed elements. So there is autonomous detection of voids. Then we can get a quantification of the extrudability and the workability properties when the printing is happening, and using the temporal variation study, we can assess the buildability properties also. So these are my major results and conclusions, and thank you. I am open for questions.
Thank you very much.